Hello, Ms. Robertson. This is my question number 3 for my long verbal response assignment. The question asked me to use the concavity test to find the intervals on which the curve is concave upward or downward, and state the points of inflection. In order to do that, I would take the first derivative and the second derivative of the function. I would end up with 12x squared minus 18x plus 6, and 6 would become my greatest common factor. To find the critical points, I would set the second derivative equals to 0. That means this whole part would be equal to 0. So I would factor 2x squared minus 3x plus 1, and I would end up with x minus 1 times 2x minus 1. So my x's would be x equals 1 and x equals 1 and 1 over 2. Having the critical points, I would set up my intervals. My first interval is from negative infinity to 1/2. My second one is from 1/2 to 1, and my last one will be from 1 to infinity. And by doing that, by just substituting the value in between the interval in the function, I would have the second derivative. I would know if the second derivative is greater or less than 0, and I would also know which part is concaving upward or downward. So I would have the first interval concaving upward, the second one is concaving downward, and the third one is concaving upward. Therefore I have two inflection points. One is at 1.5 and the other one is at 1. By substituting the axis, by substituting my critical point back into the original function, I would have the coordinate of y. I would have the value of y. For 1/2 is 15 over 16, and for 1 I would have 1. Yep, that's it for my question number 3.